Hello students, good time to all. I am Chandan Kumar Pradhan. Welcome to the YouTube channel Chandan Physics. In this video, we are going to discuss equation of an adiabatic process and isothermal process. Let's begin. Adiabatic process is the type of thermodynamic process in which heat is treated as constant, means the change of heat in that of particular system is 0. So, how to derive the equation of an adiabatic process? So, to derive the equation of an adiabatic process, let us consider a 1 mole of an ideal gas, 1 mole of an ideal gas is enclosed in a perfectly elastic container. 1 mole of ideal gas that enclosed in a perfectly elastic container, as we have discussed in previous videos how the container looks like. It is perfectly elastic and a piston is, this is the piston is situated here. So, in that of container we take 1 mole of ideal gas and that container is perfectly elastic in nature, that is perfectly not elastic, that is perfectly insulated, perfectly insulated in the sense throughout the process heat is said to be constant or the change of heat will be 0, since the process is carried out through that of adiabatic process. And here let Cp, that is the specific heats of gas at constant pressure, specific heats of gas at constant pressure, and Cv, specific heats of gas at constant volume, and let that gas is allowed to expand, here the quantities like pressure P, volume V, and temperature T. These quantities are said to be, these quantities of that of gas are said to be changes. These quantities are changed since the gas is allowed to expand. So, according to first law of thermodynamics, according to first law of thermodynamics, when we supply some amount of heat to that of system, that is used in change in internal energy and some kind of work done against that of external pressure, dq is equal to du plus dw, where dq is the amount of heat supplied to that of gas, du is the increase in internal energy of that gas, and dw, or we can say it at the pdv, dq du plus pdv, that is the work done by that of gas against external pressure. Here we know du is equal to cv dt plus pdv. As we know, Cv is equal to du Cv is equal to du by dt are constant volume, therefore du is equal to Cv dt. So in place of du we can substitute Cv dt, whereas dt is the change in temperature, dt where dt is the change in temperature, so that equation will be dq is equal to Cv dt plus pdv. And again, since the process is carried out throughout that of adiabatic process, or that process is said to be adiabatic, means the heat will be constant. So dq is equal to 0 Cv dt plus p dv. Therefore dq, the change of that of heat will be 0, since that is adiabatic process, in adiabatic process heat will be constant and the change of heat will be 0, and that equation Cv dt plus pdv is equal to 0. Write it, Cv dt plus pdv is equal to 0. Let me prefer it as equation number 1. If we consider the ideal gas equation, according to, since we consider 1 mole of ideal gas, so it will obey the ideal gas equation. We know from that of ideal gas equation, we know the ideal gas equation, that is PV is equal to nRT, or PV is equal to RT, where n is equal to 1, as we consider 1 mole of gas, 1 mole of ideal gas. That's why the value of n will be 1, PV is equal to RT. Now differentiating both sides, we get, now differentiating PV is equal to RT, that is pdv plus vdp, R is the constant, that is universal gas constant, so that is R dt. Now from that of equation dt written as pdv plus vdp divided by what? Divided by R. Let me choose it as equation number 2. Now putting the value of dt in equation 1, putting the value of dt in equation 1, we get Cv in place of dt we substitute p dv plus v dp divided by R plus pdv is equal to 0. Let us multiply R on both sides. Now multiplying R on both sides, what we have, that is Cv p dv plus v dp plus R p dv is equal to 0. Multiplying R on both sides, expanding that bracket, that is Cv pdv plus Cv vdp plus Rp dv is equal to 0. In place of Cv, we can substitute Cv. Let from these two terms PdV, here is PdV, taking as PdV as common, so Cv plus R of PdV plus Cv V dP is equal to 0, taking common from this from the two terms as PdV here. So Cv plus R, it is Cp PdV plus Cv Vdp is equal to 0. As we know, Cp minus Cv is equal to R. Therefore, in place of Cv plus R, it will be Cp. Now, dividing both sides by Cv Vp. So here I write dividing both sides by Cv Vp. Cv Vp, we get, let divide Cv V into P. So it will be Cp PdV divided by Cv Vp plus Cv Vdp divided by Cv Vp is equal to 0, or 1p cancel out, Cp by Cv. So Cp by Cv dV by V plus Vv Cv cancel out, dP by P is equal to 0. So Cp by Cv is equal to gamma dV by V plus dP by P is equal to 0. As we know, for that of 1 mole of gas, it will be Cp by Cv. Cp by Cv is always constant, that is gamma, for 1 mole gas. Cp by Cv is equal to gamma. Now integrating both sides, both sides, we get, integrating both sides, we have integration over gamma dV by V plus integration over dP by P is equal to 0. And here we take or here when we integrate that one, let us say that is k is the constant, let us say that is the constant, where k is the constant or constant of integration, that is the constant, that is integrating constant. So that is gamma as constant to outside. So dV by V integration over dV by V plus integration over dP by P is equal to k, or gamma integration over dP by V, that is log V base E plus here log P base E is equal to K, or that is log V to the power gamma base E plus log P base E is equal to K. Here log A plus log B, that means log AB. So log V to the power gamma P say that is also K is the constant. Constant means that will be a constant. Let I suppose log K base E. There will be no such change, means that is the all total constant said to be that one. So log cancel out from both sides. We take P V to the power gamma V to the power gamma is the constant. Where let us say that constant, that is log of that constant, that is the another constant. Here K is another constant. This is the constant term here. So P V to the power gamma is equal to K. That is the equation of adiabatic process. This is the equation, this is the equation of adiabatic process in terms of pressure and volume, that is in terms of P and V of an ideal gas, Let again we can derive the equation of that of ideal gas for adiabatic process in terms of volume, temperature, in terms of pressure, temperature. So various forms are derived. So let me say, since PV is equal to RT, that is for ideal gas equation. This is the gas equation. From that of equation we say P is equal to RT by V. Let us say that is the equation number 3 here. So putting this value in equation 3, putting the value P in equation 3, what we get? So in place of P we substitute RT by V, the V to the power gamma is equal to K. So simplifying that one, we get RT V to the power gamma minus 1 is equal to K. Or T V to the power gamma minus 1 is equal to K by R. K by R, K is the constant, R is the constant. So K by R is a constant. So T V to the power gamma minus 1 is the constant, This is the equation of an adiabatic process in terms of temperature and volume. Again look here, P is equal to RT by V. From this we say V is equal to RT by P. So putting the value V, the value of V in equation 3, putting the value of V in equation 3 is P. In place of V we substitute RT by P to the power gamma is equal to K, or it is P R to the power gamma T to the power gamma divided by P to the power gamma is equal to K, or P 1 minus gamma T to the power gamma is equal to K divided by R to the power gamma, K divided by R to the power gamma, that term is a constant term. So we write here P to the power 1 minus gamma T to the power gamma is equal to a constant. That is again the equation of adiabatic process in terms of pressure and temperature, that is in terms of temperature and volume, that is in terms of pressure and temperature. This is all about the equation of an adiabatic process. Now we derive what should be the equation of an isothermal process. So we write equation of an isothermal process. Isothermal process, isothermal in the sense the process, throughout that of process the temperature treat as constant, or we can say the change in temperature will be 0. So what should be the equation of an isothermal process? Again we consider 1 mole of an ideal gas, so that ideal gas equation, from gas equation we write PV is equal to RT. Here we consider 1 mole of gas, so PV is equal to RT. Here P is the pressure, V is the volume, and R is the universal gas constant, and T is the temperature. And since this is an isothermal process, since PV is equal to constant, since it is an isothermal process, so temperature T is constant. Here temperature is constant, in universal gas that is the constant, so multiplication of these two constants results a constant. So PV is equal to constant, PV is equal to constant. That is the equation of an isothermal process. Here if we consider the gas should expand from initial to final state, in initial state state of gas, we say it is the pressure be P1 and the volume be V1. This is the pressure, and that is the volume. And again after expansion, that means in that of final state, in the final state of gas, it will be P2 and V2, pressure change to P2 and volume change to V2. Therefore from that of isothermal process, the equation of that of isothermal process will be what? P1 V1 is equal to P2 V2, according to the equation of an isothermal process, we write P1 V1 is same as P2 V2, means the product of pressure and volume results a constant. P1 V1 is same as that of P2 V2, just to use the equation of an isothermal process. So With the help of this visual lecture, we understand the equation of an adiabatic process. We proceed like this. Simple mathematics applied here. Pv to the power gamma is equal to k, that is the constant term, that is the constant k. Okay. Then equation of adiabatic process in terms of temperature and volume in terms of pressure and temperature. Then equation of an isothermal process, that is Pv is equal to constant. This is all about the equation of an adiabatic process and isothermal process. In adiabatic process, it will be Pv to the power gamma is constant, and in isothermal process, that is pressure into volume is gives rise to same result as constant. Pressure into volume is constant. So, with this useful and informative notes, let me wind up this session. Thank you.